This is a video for AQA Further Pure Mathematics, Algebra and Graphs, section 1.4. In this video we're going to be looking at a couple of examples that are slightly different to sketching that we've done previously. So the first one here is x squared minus 4x over x squared plus 1. So we just need to go through the usual procedure. First of all, if y is equal to 0, we have that x squared minus 4x is equal to 0, and therefore x equals 0 or 4. So we've got 2 points on the x-axis, one at 0, one at 4, where the graph crosses the x-axis. For there to be vertical asymptotes, we would need the denominator x squared plus 1 equal to 0, but of course x squared plus 1 is greater than 0 for all values of x. So therefore there are no vertical asymptotes. But what about horizontal asymptotes? We get a horizontal asymptote when we consider what happens when x approaches plus or minus infinity. And we can see from there that y approaches x squared minus 4x over x squared. Now that's going to be approaching 1, but I've left the 4x in there because it gives us a clue as to how it approaches 1. Because for plus infinity, if x is approaching plus infinity, then x squared minus 4x is always less than x squared. So it's going to approach, y approaches 1 from below. It's always less than 1. And if we consider negative infinity, then we can see that x squared minus 4x is always bigger than x squared. So therefore y approaches 1 from above. So we've got a horizontal asymptote at y is equal to 1. Remember, this is only for large values of x, and it's approaching from below for large positive values and above for large negative values. It's going to change from being positive to negative at between 0 and 4. So between 0 and 4 there must be a negative value. These are critical values. So it must come down to some minimum point and then rise back up again before being asymptotic to the line y equal to 1. And then to the left of the y-axis we must have some maximum point which is greater than 1. So it rises up here and then comes back down again so that it's asymptotic at y is equal to 1. If we wanted to calculate the maximum point there and the minimum point, we could solve the equation x squared minus 4x over x squared plus 1 equal to k. And of course that will have one solution. And that idea we covered in a previous video, so I won't go through it now. Well, just to see what a graph plotter makes of this rather than our sketch, and here we have it. And you can see those maximum minimum points, which you may be asked to find in some exam questions. The next one I want to consider is this one here, which is x squared plus 4 over x squared minus 5x minus 6. Now this time you can see that x squared plus 4 is always greater than 0, so there are no zeros on the x-axis, so there are no values that make y equal to 0. x squared minus 5x minus 6 is equal to x minus 6 and x plus 1. So therefore we've got vertical asymptotes at x equal to negative 1 and x equal to 6. So these are the asymptotes. So draw those in, dotted in negative 1 and dotted in at 6. So these give us two critical values, and we could check quite easily that to the left of negative 1, then we have got the top line is definitely positive and the bottom line is also positive. So it's going to be positive to the left of negative 1. It then turns negative and becomes positive again to the right of 6. That means then that there must be some maximum point between negative 1 and 6. We ought to check what happens when x is equal to 0. So when x is equal to 0, we get that y is equal to negative 4 over 6. So somewhere around about here it's going to come to 0, but then reaches a maximum. It doesn't go above the axis. So it reaches a maximum here and then comes back down to be asymptotic vertical line x equal to 6. What about when x approaches plus or minus infinity? Then again you can see that y is approaching x squared over x. So x squared over x squared, I beg your pardon, which is equal to 1. So again we've got this approaching 1 for large values. But then we have to think about, well, what direction does it approach 1? So when x is large and positive, we can see that x squared plus 4 over x squared minus 5x minus 6 is always going to be greater than 1. So y is greater than 1, so it approaches from above. And when x approaches negative infinity, then you can see that the bottom line is going to be greater than the top line. So you've got x squared minus 5x, and remember that x is negative, and that's going to be greater than x squared plus 4. So y is less than 1. So it's approaching from below. Now again, we must have our asymptote here being positive to the left of negative 1. So we've got to come down and then cross that asymptote somewhere and come back up again. So remember that this asymptote here is only for large values. So really, in some ways, we should only draw the dotted line in this position here. There's nothing wrong with the line coming down below that asymptote and then back up again. But remember that it's going to be positive all the time, so it never drops below the x-axis. We didn't have any values for which we had y is equal to 0. To the right of 6, then it's positive at the asymptote and then comes down always greater than 1. So the little bit of trick in that question there would be that it's crossing this asymptote. But if you remember that the asymptote is only for large negative values or large positive values, so in some ways it might help if we were to, or you were to, just indicate the asymptotes in the very large portion of the graph, and for it not to be appearing in the other parts. I've got again a graph plotted version of this. There it is, so you can see those asymptotes nicely done. And again, the actual value of the maximum is not always going to be asked for, but do remember that if it doesn't cross the x-axis, so you've calculated that it doesn't get greater than 0 in the region between -1 and 6, make sure that your graph doesn't cross. And that's the end of this video and the end of the series of videos on sketching these graphs.